Hello. We are going to talk about the unit circle today and special right triangles, and that is where the whole unit circle comes from, in fact. So last week we talked about these special right triangles here. We have the 30, 60, 90, and these are both 30, 60, 90 in a slightly different orientation because you're going to see we're going to use one for parts of the unit circle and one for the other parts. And then we have this 45, 45, 90. And what we're going to do is all of these ordered pairs here that you see, we're going to be able to either find using our logic what we know about circles and or special right triangles. So let's start with the logic part because that will hopefully make a little bit more sense. So what we're going to do is think about these ordered pairs right here. So if this is the origin, the center of our XY axis, so this is my Y axis and this is my X axis, then this is the point 0, 0. So I said that I have a radius of 1. So if I go all the way out to this point here, that's a radius of 1. So I've gone out 1, but I've gone up 0. So my X value is 1 and my Y value is 0. Okay, I can do that one because it's a perfectly horizontal line. I can also do a perfectly vertical line right here. And again, this would be going up 1. I'm going left and right 0. So my X value is 0, but I'm rising 1 for my Y values. Okay, now I'm going to the left. And we know when we go in the left direction, we're going to be negative. So this is going to be negative 1 here because we went in the negative direction. And then just 0 because we didn't go up or down at all. Okay, same idea, straight down to that point there on my circle. And that is going to be the point 0. We didn't go left or right at all. And then we went down 1, negative 1. So let's kind of think about these quadrants really quickly and when they are positive versus negative. So if we have a ordered pair in this quadrant, in quadrant 1, so this is quadrant 1 over here, this is going to be a positive X value and a positive Y value, right? If we have quadrant 2, now our X value will be negative, but our Y value is still going to be positive. So our X will be negative, but our Y will be positive. And then in quadrant 3, over here's quadrant 4, right? In quadrant 3, both of my values will be negative, negative X, negative Y. And last but not least, over here, my X values will be positive, but my Y values will be negative. What color was I using? Green, okay. Positive, negative. So keep that in mind as you go around the unit circle. It's going to be very important when you're looking at these patterns to understand why they are the way they are. Okay, next, if we were to draw, boop, 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 a little unit circle there. It's not the same exact blue, but basically this is my 30, 60, 90, right? So I have a 30-degree angle here, a 60-degree angle here, and obviously my 90-degree angle right there. Well, now we solved for this last week, so look back if you need to, but if you have a hypotenuse of 1 in a special right triangle, the short leg will be 1/2, and the long leg will be square root 3 over 2. Again, double check that with last week's video if you need it. So over here, this long leg is square root 3 over 2, and then the short leg is just 1/2. Now on a 45, 45, 90, we get a little bit luckier because now we have identical legs, right? These legs have to be the same because they both are opposite 45-degree angles, and we know that angles on their opposite sides have a special relationship. So these side lengths are identical. Okay, so now what we're doing is looking at our X and Y coordinates if we had traveled this unit circle. So if I went over this amount, this would be my X amount right here. So my long leg is going to be my X value. So my X value here is going to be square root 3 over 2. All right, what if I was going my height, my vertical distance here? My vertical distance here is going to be the short leg. This is going to be a distance of 1/2. So this is 1/2. Okay, so if you were to take all of these and just draw your special right triangles, notice my inverted 30, 60, 90, my kind of flipped so that the long leg is now out facing or touching my circle right here, right? So that's just a flipped 30, 60, 90. So guess what? My ordered pairs are just going to flip. I'm going to have 1/2 over here and then square root 3 over 2 here. Because I traveled, my x value is going to be the short leg, now it's only 1/2, and my y value is going to be the longer leg, or square root 3 over 2. All right, last but not least, let's look at our 45, 45, 90. Well, this one's easier again because we know the legs are the same length. So I go over square root 2 over 2, and I go up square root 2 over 2. And that's how we build this unit circle. Now, this is really, really cool thing about this. Trig and the unit circle have a special relationship. So if I want to know some value, some angle, or some trig function of the degree 30, like sine, cosine, or tangent, I can use these special right triangle values to determine what that is. And in the unit circle, it mirrors these because we have a hypotenuse of 1. Okay, so let's look at what I mean by that. So if we wanted to do sine, we would do opposite, our vertical height here, our 1/2, opposite over hypotenuse. Well, that's going to be 1/2 just divided by 1. So guess what the sine of 30 is? 1/2. So sine of 30 equals 1/2. Easy peasy, because we just look at our y value here. So one thing you want to pay attention to is that x is going to correspond with cosine measurements, horizontal measurements, and y is going to correspond with sine measurements. So what I mean by that again is when I looked at opposite, it was a vertical height. Same thing if I were to come to my 45, 45, 90 over here, opposite would be my vertical height. Same thing on my 30, 60, 90 that's inverted. This is a 60-degree angle. Opposite my 60 would be my sine measurement. Opposite, and because the hypotenuse is always 1, it just ends up being this ordered pair. So guess what the sine of 60 is? Square root 3 over 2. So what would the cosine of 30 be? Well, 30 cosine is adjacent. Now I'm talking about my horizontal measurements, right? So cosine is going to correspond with my x values here. So I'm going horizontally, square root 3 over 2. So the cosine of 30 is square root 3 over 2, and that's the exact value. So when you do the Khan Academy, they're looking for these exact values that come from the unit circle. Okay, last but not least, the challenging one is tangent. So remember that tangent is a relationship of opposite over adjacent. So this one's slightly more complicated because in this case, we don't have 1 to divide by, so we actually have to do some math here. So if we wanted to do tangent of 30, for example, we would look down at our special right triangle right here, 30 degrees. My opposite would be 1/2. My adjacent is going to be square root 3 over 2. So opposite would be 1/2. And adjacent would be square root 3 over 2. Okay, if you see a fraction being divided by a fraction, the easiest way to handle that is to just write it as a division problem. 1/2 divided by square root 3 over 2, because then it looks less intimidating, right? So 1/2 divided by square root of 2. Remember, when we divide with fractions, we invert and multiply. So we multiply by 2 over square root of 3. The 2's cancel, and I end up with 1 over the square root of 3. But of course, we're not allowed to have a radical in the denominator, so I'm going to multiply by the square root of 3 over the square root of 3, which is just 1, and I end up with square root 3 over 3. So the tangent of 30 takes a little bit more work, but it's just square root 3 over 3 if you wanted the exact value. Now, if you plug square root 3 divided by 3 in your calculator, and then you take the tangent of 30 and plug that into your calculator, those values will be the same. Okay, so I'm going to look down at this completed unit circle. You need to copy all of this information in, but let's just talk about where these pieces come from and why they matter. So this is going to be our degree measure. This is going to be our radians measure. So now let's talk about how we get from one to the other. So notice degrees, let's look over here actually. This will give us a hint. So when I have 180 degrees, I have pi radians. When I have 360 degree, I get 2 pi radians, which makes sense, right? This one doubles, this one doubles, this one doubles, this one doubles. So radians are just another measurement for angle, just like degrees are a measure for angle, just like inches are a measure for length or centimeters are a measure for length. This is just another way of measuring angles. So these values are equivalent. 30 degrees is equivalent to pi over 6 radians. Okay, let's talk about how we get this. We are going to take our degree, which I did in this dark blue color. We're going to take our degree, and we are going to multiply by, and this is just the rule, pi over 180, and that will give us our radians. Okay, so let's check that. Radians. Let's check it. So if I take my degree of 180, let's look at that one. If I take 180 and I multiply by pi over 180, so if I take 180 and multiply by pi over 180, my 180s cancel out and I'm left with pi. So that equation works. So that's how these radians are coming. So if we want to get from degrees to radians, we take our degrees and we multiply by pi over 180. If you want to go backward, if you wanted to go from radians down to degrees, you would take this and multiply by the inverse, 180 over pi, and that would get you back to your degree. So that's how we go between degrees and radians. Again, this is going to be key for that. Make sure you write this down. This is your equation. Degrees times pi over 180 will equal your radians. If you mess with that equation, you can solve for degrees instead of radians. Okay, so the big gaps are 30-degree gaps. This is a 30-degree angle right here. Then notice we have a couple smaller gaps in here. To go from 30 to the next one is a 15-degree jump. 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30. You see the pattern here? So pay attention to these patterns. This unit circle is all about patterns. All right, so remember we drew those right triangles up above before, and hello? Oh, something's happening here. Anyway, we drew these right triangles before, our special right triangles, right? So we know if we were to draw a special right triangle here, this would also be a 30, 60, 90, even though what we're measuring is this entire degree here, all the way to 180. If I were to draw my special right triangle in there, let's try that again. Nope, won't work. Then I would be able to just flip that over. So every single one of these is built off of the special right triangles. So these are going to be exactly the same over here, except that my x values will be negative. These are going to be exactly the same over here, except my x values will be negative. Okay, same thing here. If I were to draw my 30, 60, 90 right here, this is going to be the same as this one, except now, guess what? They're both negative. Okay, so pay attention to these patterns, how these triangles are being moved around. Your job this week is to get comfortable with what this unit circle looks like. Make sure you write this down, look at it a few times, pay attention to it. And then also to understand that your exact trig values are going to come from these ordered pairs on the unit circle. Hope you're well. Miss you all.